Okay. Hello everyone. Good evening. Can you hear me? Hello.
Hello, good evening, sir.
Okay. So can you hear me? Yeah.
Hello.
Okay. So now we are waiting. Okay. So another person also join. Okay. So now we will start our today's online training program. So let's go. I simply share my screen. Can you see my screen now? Okay. So hi and welcome to the online training program on air and water quality monitoring using remote sensing technique and using the Google Earth Engine platform. Okay, so previous class we also try to discuss about the air quality parameters, different types of air quality parameters, how we can easily make the different types of analysis. We also try to complete it. Today I will try to discuss about the water quality monitoring. So mainly in this time I try to discuss about the some water quality parameters such as total suspended solid, then normalized difference chlorophyll index, then turbidity. How we can get the all of those parameters result from the remote sensing technique, and then we also implement this technique in Google Earth Engine platform. Okay, so let's go our today's class. So first of all, I try to discuss about the NDTI. It is the normalized difference turbidity index. Then we also try to discuss about the NDCI. This is the normalized difference chlorophyll index. Then we also try to discuss about that NDWI. Normally, we already know about that NDWI. So it's very commonly used for identify the water pixel value on the surface. NDWI or normalized difference water index. Then we also try to discuss about that AWEI. This is the automated water extraction index. Okay, how we can easily use the index and extract the water. We also try to discuss about this. Then we also try to discuss about the total suspended remote sensing model, how we can easily implement this model in Google Earth Engine platform, write the code. Okay. Then we also try to discuss about the turbidity model, how we can easily get the turbidity using the remote sensing model and implement this in coding in Google Earth Engine platform. Then we also try to discuss about the chlorophyll index or chlorophyll, how we can easily get the chlorophyll result. We also try to discuss. And after this, all of the things, we make the time series chart so that we can easily identify the temporal changes for the total suspended solid, turbidity, and chlorophyll. We can make the time series chart. Okay, so let's go. And then we also try to make the animation. So mainly animation, this part I will add you with our last class. So in our when I talk about the web application, then I also try to discuss about the animation. So because animation, when you want to work with the animation, then lot of code will be added with this animation for the making the animation, for the changing animation. Okay, so that's why I will add this code with the web application part. When I want to show you the how you can easily make the web application using the Google Earth Engine platform, then I also try to show you this part, how you can easily make the changing animation. So mainly today I will try to discuss about that all of the index, and then how you can easily make the total suspended solid, turbidity, and chlorophyll map, as well as also make the time series chart, all of the map. Okay, so let's go. So first of all, NDCI. So mainly NDCI, it's the normalized difference chlorophyll index, and mainly we are using this index for estimating the of chlorophyll A concentration in the turbid water. Okay, and it's calculated using the red spectral band, mainly for the Sentinel 2. This is the band 4. and also with the red is spectral band, mainly it's the band 5. Okay, so we are using this two band 4 and band 5 for estimating or calculating the NDCI. Okay, so in this time, change in turbidity, suppose you can see this is the algorithm. So mainly when you want to work with the, suppose in this time this is the lake of Hatirji Lake in Dhaka city. In this time we try to make the turbidity. Okay, so where the turbidity is high, we identify this is the polluted water, and where the turbidity is the low, we identify this is the normal water. Okay, and we also add the legend look like this. Okay, so in this time we also try to implement this model and then try to make the change in turbidity map for this lake in Google Earth Engine platform according to this algorithm. Okay, so let's go. And what is the process when you want to make the NDCI map or normalized difference chlorophyll index map? So first of all, you need to select your water body. So suppose you want to work with the any water body. Suppose it can be Hatirji Lake or any river water. So first of all, you can simply select your water body. So it can be river, it can be lake or other types of water body. You can simply select the water body. Then you need to filtering the satellite image. Okay, so in this time I use here the Sentinel-2 multispectral instrument level 2A. This satellite image I used for making the NDCI. Okay, and then after this satellite image, when you can get the satellite image, from this satellite image you want to extract or you want to watermarks from this satellite imagery. So mainly when you want to identify the watermarks, we need to use here the NDWI index or normalized difference water index. Okay, so that's why I can easily get the water on the surface, or we can easily watermarks only for the water. Okay, then apply the NDCI formula or NDCI equation, normalized difference chlorophyll index equation, then we can display the map. Okay, so let's go our code editor and try to implement this. So I simply open, we can go to the step by step. So after completing this, then we also try to discuss about that automated water extraction index and how it will be work. So let's go our code editor. Okay, so I simply open my code editor. So in this time, first of all, I select my area or water body area I want to select. So if you want, you can simply select the area, water body area from this tool, draw a shape. Suppose you can see, I want to work with this water body such as Hatirji Lake. I want to work with this. Okay, suppose you can see this is the Hatirji Lake. I want to need the NDCI or change the turbidity map for this region. Okay, so first of all, you can simply click here the draw a shape. Then you can simply digitizing your water body area or water body shape file. You can simply digitizing. Okay, so here I already digitizing this shape file. So in this time I simply remove this and then I simply just import this shape file. Okay, so I already do this part. So and also stored this shape file in my asset tab. So in this time I simply find out the shape file of the Hatirji Lake. So I just simply find out.
Sir, how you create that point?
You can see this is my shape. Okay. Okay. Did you know the part how you can easily create the shape file?
Sir, in ArcGIS, I know how to create shapefile, but means I missed that step, sir. Now.
Okay.
How
So we also
yes.
create the shapefile in Google Earth Engine platform. Okay, so I also try to show you this part how you can easily create the shapefile. So this shapefile I created from the Earth Engine platform. Okay, so just a minute, I also try to show you this part how you can easily create the shapefile. So it is very easy way. Suppose you want to need this water body shape file of Hatirjil area. So you can simply click on a draw a shape and then simply digitize your area. If you want, you can also use the satellite image for better view of this water body. You can also zoom. So you can very carefully digitize your area. So in the short time, I simply randomly take this area. Okay, so I simply take this area, look like this, and also get the short area for showing the how you can easily get the shape file from this Google Earth Engine platform. Okay, so I can simply do this. Suppose this is my area. This area I want to need the shape file. So I digitize this, and I get the totally georeference shape file, so that I can easily use the shape file for other GIS software like art. So you can see this is my area. So I simply digitize my area. Suppose this area I want to create the shape file. After this, you can simply it's showing the geometry default name. If you want, you can simply change it AOI or any name you can put, no problem. In this time, I want to convert it as a feature collection. Okay, so for this I simply take a variable, and I take a variable and give the variable name is that suppose collection. Okay, in this collection I simply use here the ee dot feature collection. Okay, then I simply call the AOI. This variable I simply put here the AOI. So now I can simply write this code, export dot table to drive, and put all of the argument one by one. I simply make a dictionary. I start here the curly bracket start, as well as also curly bracket in. Then first of all, collection mainly your feature collection, and your feature collection is stored in a variable collection. I simply copy the variable and paste here. This is my key value. Okay, then description, it can be anything. It is a file name, so I simply put the file name as that lake. You can put any name. Then you can simply put the folder name. Suppose I put the folder name is that ROI. You can put any name. Okay, then all of it's not needed for this time. File format is needed. In this time I want to extract the shape file. I simply use the SSP. It's the uppercase SSP. Then selector not needed for this time. Vertex not needed. Then click to the run. So now you can see our task tab will be running, and from this task tab, when I click on this run and click, you can see shape file. If you want, you can also KML file, KMZ file, you can easily export. I simply need the shape file. So I simply click the shape file and click to the run. So now you can see it will be extracting this shape file. Okay, after completing this, I can simply open this shape file. Okay, any software, just ArcMap or QGIS software, I can simply work with this. So it will be working. After completing the right sign in here, I can easily work with this. Okay, so this is the process for creating the shape file in Google Earth Engine platform. Okay, so using this process, you can easily create any water body shape file, any river shape file, any lake shape file, or anything shape file you can easily get from this process. Okay, so in this time, I just try to show you this part. Here, this shape file I already imported also. Okay, so remove. Okay, so you can see done. So I simply go to the open in drive, and in this time I can get all of the shape file. You can see .a68, SSP, PRJ, DBF, CPZ, fix. I can get all of the file of the shape file. Okay, so now I can simply download the shape file. You can simply click here and download. The shape file is downloaded. Then you can simply open the shape file in any software, ArcMap or QGIS software, as well as you can also import the shape file in Google Earth Engine platform also. Okay, so this is the process for making the shape file. And this shape file I already make for the Hatirjil Lake, and I already imported the shape file in Google Earth Engine platform. So now I just simply open the shape file. You can see this is my shape file, and I want to work with the shape file. So for this I simply import the shape file. You can see import. Okay, so I simply click on the import. So now you can see it will be imported. Okay, and it's showing the default name is the table. If you want, you can change the name. I simply change the name as such as ROI. You can put any name. Okay, so now I want to show the layer. I simply use here the map dot add layer, and then simply use here the ROI. Okay, And I also focus the center of the shapefile. I simply use here the map dot center object, and then use here the ROI and put zoom level 10 and click to run. So now you can see I can get this shapefile. I also need to increasing the zoom level. I simply put here the suppose 16 and click to run again. Okay, you can see this is my shapefile. This shapefile I created from the Google Earth Engine platform, as well as I also import the shapefile in Google Earth Engine platform and then open this. So now this water body, I want to calculate the change in turbidity using the NDCI or normalized difference chlorophyll index. Okay, so I get this satellite image. In this time, I want to import my image collection, which image I want to use. So in this time, I want to work with the Sentinel-2 image collection. Okay, so for this, I simply search here. Or if you want, you can simply see my slide. In this slide, I already defined the image collection name. So, okay, so I simply copy this name from here. Just simply copy this name and search in the top of the code editor, so that I can easily find out this image collection. Okay, so this is my image collection. I want to get second, yeah. So you can see surface reflectance. I want to use the multi-spectral instrument surface reflectance satellite images for getting this NDCI. Okay. So in this time, I just simply, if you want, you can simply click on the import button. Okay. Or if you want, you can simply click the collection snippet also. So I can simply copy the collection snippet from copy, and then I simply paste here. Okay. After this, I simply take a variable name. You can use any variable name. I simply take the variable name is that, suppose it is a lowercase r. I simply put the variable name is the img. You can put any name. Okay. So now you can see the full image collection is stored in a variable image. Okay, it is stored. So now I simply use here the different types of function, such as filter bounds function, filter date function, as well as filter metadata function, fast function. All of the function I use here. Okay, so basically in this time I will not discuss a lot of things, because this only for the water quality monitoring classes. But when you want to learn the more details about the how you can easily work with the filtering and visualizing satellite image, all of the detailed things, then we have also another online training program for this. Okay, so in this time I just getting the image. After getting the image, this image I extract the water pixel value. After this I simply apply the NDCI formula, and then I can check the what is the chlorophyll index high and low, and where I can get the chlorophyll index is the high, it's identify that water is the high turbidity, and then we can find out this is the polluted water. And when I can get the low, it's identify the normal water. Okay, so let's go. I simply use here the filter bounds function. Use here the dot net filter bounds. Okay, filter bounds. So mainly filter bounds is a function. I also try to discuss explain the filter bounds. So mainly filter bounds function, it intersecting with your whole collection with the region of interest. In this time you can see I need the satellite images only for this boundary area. Okay, only for this boundary area. So that's why I simply use here the filter bounds function, and then I simply write here my boundary area variable name, and my boundary is already stored in a variable RY. Okay, I simply copy the RY and paste here. Okay, so now I can get only for the satellite image for this region of interest, or for this shapefile. Okay, in this time I want to filter. Suppose I want to need the satellite image, or I want to need the NDCI map for a specific time period or a specific season. Okay, so I simply use here this filter date function. Okay, then I define here the start date and end date. Suppose I want to work with for year of 2021, 1st January, from year of 2021 December 31. Okay, this is my observation time period. Okay, so in this time, suppose in this time, between this time period for the year of 2021, I need a satellite image, any date. I don't know what is the date I want to get. Any date satellite image, which image is the very low cloud pixel, very low cloud pixel. So in this time, what's the date I want to get the low pixel value of cloud? I don't know. So that's why in this time I use here the short function or shorting. Okay, so short is a function. So mainly in this time I sort according to the cloud pixel percentage. So I simply use here the sort function, and then I simply go to this image properties. You can see I sort according to the cloud pixel percentage. I simply copy this properties name from here, and then I simply paste here. Okay, and then I simply get the first image. So I simply use here the first. Okay, and after the first image I simply use here the clip function, clip with my region of interest RY. Okay, so now I want to show the image in this area. So for this I simply show the layer, another layer for the image. I simply use here the map dot add layer, and then I simply call the img and click to the front. So now you can see now it added a satellite image only for this region, and this satellite image I want to use for making the change in turbidity. You can see I can totally get the black color image because I did not use. So now you can see here I can get this satellite image, but I did not use any visualization. I simply add the visualization. Just a minute. So now you can I can simply try to show you this part. I want to add here the click to here and add here the B4 true color composite B4, B3 and B2. Also increase the 98% for better looking. So then I simply apply. You can see now we can get the true color composite of the satellite images. Okay, look like this. Okay, in this satellite image we are using for getting the water quality NDTI. Okay, in this time I simply import this satellite image. I simply import the visualization, and after this I simply use here the image visualization. This variable I simply copy, and after the object name I simply paste the visualization variable name. Okay, then I simply put the layer name. Suppose this layer is that true color. You can use any name. I simply use here the color. Okay, then okay, so in this time I also need to add here the another thing is that I need to use here the true. Here you true. Then check again. Okay, okay. So now I can get the satellite images. In this time from this satellite images I want to extract the water body. Okay, so I want to extract the water body, and from this water body I want to calculate the NDCI. Okay, so in this time we already know about that NDWI formula. What is the NDWI formula? NDWI formula is that so NDWI, this formula is that near green minus near infrared band. So green minus near infrared band divided by green plus near infrared band. Okay, so this is my formula. In this time I use this formula, and then I want to extract watermarks for this from this satellite images. I want to watermarks. Okay, so then I simply work with this. So I simply take a variable and give the variable name is that suppose NDWI. NDWI. I simply put this NDWI. Suppose I want to create a function. Okay, so for this, okay, I want to create the function. So for this I simply take a variable name. Suppose this variable name is that NDWI. You can put any name, no problem. Then I simply use here the function keyword. Okay, after the function keyword I need to define an element name. Suppose image. Okay, then I use here the curly bracket. In this curly bracket I define my argument what I need. In this time I want to need the NDWI. I calculated the NDWI, and then this NDWI I want to extract only for the water pixel value from the satellite images. Okay, so for this I simply take a variable. Suppose this variable name is the NDWI, and I want to calculate this equation. Okay, calculate this equation. We are using the different way for calculating this type of indices. So in this time I use here the normal way. Normal way is that we use here the built-in function. This built-in function is that normalized difference. Normalized difference. So this is the built-in function. When I use the normalized difference, it automatically calculated the normalized difference between two band. So in this time, green and near infrared band. For Sentinel 2, green band is that B3 and near infrared band is the B8. So I simply put here the B3 as well as also use here the B8. Okay. So now it calculated the NDWI. Okay, and I also use here the rename function. And put the band name as that NDWI. Okay. In this time, from this NDWI, I want to return a image. I want to return this image so that this image is only showing the water pixel value from the satellite images. Okay. So for this, I just simply use a function. It's called the return function. I simply use the return function. Workes return function. I returned this image as a add bands with NDWI. I use this variable name NDWI, and then I simply update this marks. So for this update this marks, I simply use here the update marks function, and then I simply call the NDWI. I will need the only for the water pixel value. So NDWI. So mainly for the NDWI, it's identify the high positive value, identify the water pixel value. Okay, and low pixel value, negative pixel value is identify there is a no water. So for this, I simply use here the NDWI greater than such as -1. I take the greater than all of the -1 pixel value. I identify this is the only for the water. Okay. So in this time I create this function. Okay, so I create this function. In this function, what I can create, you can see I simply take a variable name NDWI f, then I simply use here the function, and then I take the element name image, and this time I want to make the curly bracket. In this curly bracket, I simply put here the element name, then I simply calculated the normalized difference. I put here the equation for B3 and B8. So mainly when you want to use the normalized difference, this built-in function, it's automatically created this type of equation. Okay, so in this time it calculated the B3 minus B8 divided by B3 plus B8. Then I also simply rename this NDWI, and then I simply return this image and add the NDWI band, and I also update this mark so that I can get the all of the pixel value greater than -1, so that I can identify the positive, and positive is NDWI is identify the water pixel value. Okay, so anyone any question in here? Anyone any question?
Sir, why you use that true in line number 7?
So your voice is very slow. I did not hear you properly.
Sir, in line number 7, you after cloud pixel percentage, you have used true. Hello, sir.
Hello.
Okay, sir. Okay.
So if possible, you can also write the message. Then it's also better. So mainly, okay. Okay, true and false. This is the boolean type. Boolean. This is the boolean. So we can get the true and false, two types of hello. So in this time, I want to, if you want to remove the true, it doesn't matter. Okay. So mainly this is the true is the default. Okay, true is the default. Okay. So in this time, I want to sort according to the cloud pixel percentage. I want to need this cloud pixel percentage sorting. I use here the true. If you want to not sorting according to the cloud pixel percentage, then you can use here the false. Okay. So it's showing the default result. Okay. It's not mandatory to use or not. Okay. And you can easily another question is that you can easily download your shapefile from, I already show you the process. I can easily download the shapefile, water body, river, lake. You can simply download digitizing this and follow this process. You can easily download this type of shapefile and work with this shapefile. Okay. I think also some sources is available for the downloading the lake or river shape file. We can easily get. Okay. So in this time, I want to need only for the water pixel value. Okay. So I want to water marks. I want to create this from this satellite image. I want to need only for the water. Okay, water pixel value. So for the NDWI, it's identify the normalized difference water index, and the negative pixel value is identify there is the no water, and highly positive value is identify there is the water. So I want to get all of the pixel value greater than -1. Okay. Okay. So in this time we are using here this NDWI. So I also try to show you the something about the basically normally we are using the NDWI. You can take. So we can get this result -1 to +1, and depending on the leaf water contact but also vegetation type or cover. So high values of NDWI is blue. So high values or positive values is identify the NDWI as a water, and high vegetation or water content the vegetation fraction cover. Low NDWI correspond to low vegetation. Okay. Okay. So in this time you can see for this I don't know, so that's why I simply select only for the water body area. Okay. So in this water body area, which pixel value I want to get greater than -1, it's identify only for the water body, because I already selected the water body. Okay. And how I can get this value? This value is normally normalized difference water index. So it's mainly this range between the -1 to +1, and this -1 is identify there is the no water. It can be vegetation, it can be different types of other feature, but not water. Okay. So greater than -1, then it also identify the water. Okay. Okay. So in this time I use here this okay. So in this time I want to just get the water pixel value. Okay. So I want to apply the function, and then I want to check, suppose I take a variable and give the variable name is that, suppose, yes, water. You can put any variable name, and after this I just simply call the ended up this function variable name. I simply call this function variable name, and then I paste here, and I add this function variable name with my image. So this is my image. I simply copy this variable name because my image is stored in this variable. Okay. I simply copy and paste here. Okay. So now display the result of the water pixel value from this image. So for this I simply show the result. I simply use here the map dot add layer function again, and in this time I simply call the image water, this variable. From this image water I want to select, I just select a band. This band name is the NDWI. And where I can get the NDWI, because you can see I rename it NDWI. I simply use here the NDWI. Okay. Okay. Then I simply add here the color. I want to show the water pixel value as a color. I want to simply use here the related and use here the color such as, suppose I want to use here the suppose blue color. So I simply use here the blue. Okay. So blue color is identify the water, and then I simply put here this. Suppose I simply put this, yes, layer name, and click to the run. Okay. Okay, so if you want, you can also check. Suppose I want to use here the greater than 0, then click to the run again. Okay, okay. So now you can see I get this result look like this. Okay, so in this time it's showing the all of the pixel value greater than 0. Okay, so now you can see this is the water pixel value. Okay, so in this time, this water pixel value you want to identify the NDCI. Okay, NDCI. So in this time I want to apply the NDCI formula. So for this formula I again use here this I make a function again. So for this I simply take a variable and give the variable name is that, suppose you can use any variable name. I simply put the variable name is that NDCI, suppose F, and then I simply use here the function keyword and put the value name is that, I can simply put here the element name is the image. Okay, I use here the curly bracket. In this curly bracket I want to define the NDCI formula. So mainly NDCI formula we are using here the red is band and red band. Okay, so these two band we going to need, you can see for the NDCI B5 and B4. Okay, red is and red band. So I want to simply calculate the difference between the two bands. So for this I simply take a variable. Suppose I simply use here this NDCI. Okay, NDCI, and then I simply call the image element name and use here the normalized difference between the two band. So this band is that B5 and B4. So 5 as well as also B4. Okay, so after this I simply rename it. So I can use here the rename function, rename, and use here the NDCI. Okay, and then I simply return this image with a band. So I simply use here the return function and case return, and after return I simply use here the miss, add a bands, and this band name is the NDCI. Okay, so I simply show the result. So in this time I just add this NDCI index with the water, so I can get the water image. In this time I also apply here the NDCI. In this time I add the NDCI function with the water image of water. So for this I simply take a variable. Suppose I simply take the variable name is that NDCI, NDCI, suppose NDCI image. Okay, then I simply call this variable name NDCI, NDCI, this function variable name NDCI F. I simply call it, add it with the water of image water. So image water is already stored in this variable. This variable name is the image water. You can see I simply use here the image water. So I simply copy this, copy and paste here. Okay, so now I want to show the result for the NDCI. So for this I simply take this layer. So map dot add layer, and then I simply call the NDCI image and paste here. Okay, after this I add the visualization, and in this time I want to add the visualization look like this. I make a dictionary in here, such as I simply use at the mean. We start from the, I simply use at the point 1 as well as also max. Suppose I use the point 4. Okay, and then it's totally depend on your, it's only for the visualization. Okay, so now I want to add here the plated function, and add here the color look like this. Suppose I want to add here the color for the cyan color for the low turbidity. Then I also use here the orange color, and then I also, for the high I want to show here the red color. Okay, and also put the layer name such as NDCI. So now I want to just click to the run. Okay, what's the problem? Okay. So I need to select the band. So I simply use the select function, select, and this band name is that NDCI. You can say I rename it and put the name is NDCI. So copy and paste here and click to the run. In this time here you can see I can get the result, but it also some area I did not get the water pixel value. Okay, so that's why I also decrease the value. I simply use at the -1, get at the -1. So I simply use at the -1, all of the -1, identify this is the water, then click to the run. And this is the one process for using here the water, get the water pixel value. Okay, but another process is that we are also use the process. I also tried this later. For this you can see it's called the this index AWEI. This is the automated water extraction index. Okay, when you use the automated water extraction index, then we don't need to use the NDWI. Okay, then you can easily use this and get this result. Okay, so the lot of way for getting the water pixel value. So NDWI is the one, and there is an AWEI index. This is the another. So in this time you can see I can get the result look like this. So this is my boundary area. This is my satellite image, and it also extract the water, and from this water we want to make the NDCI or change the chlorophyll index. And I can see we can get this. So now we can easily add the legend also in here. Suppose you want to add the legend for the showing the normal water as a polluted water, so it's also possible. So okay, so for this I already write the code for the legend. In this time I simply copy and paste here. So for this I simply copy their legend code, copy, paste here, then click to the run. Okay, so PIS. I need to use here the visualization is a PIS. So I simply take a variable and put the variable name as the VIZ, and I simply copy all of the things from here, copy and paste here. After that I simply copy the variable name and paste here. Now the legend is appearing. Okay, so this is the process for making this NDCI. Okay, and you can easily export this map as a TIFF format, and then you can easily apply the map layout or other things using the ArcMap software. The same process which I already done our previous class. Okay, so anyone any question about this? Ask me. Anyone any question here? Anyone any question about this? And exporting the same process, use the same method for export image to drive. We can easily exporting. Okay. Okay, so in this time I simply go to the next slide, and listen code is the same. So I also try to use a listen code, so it's very easy. So in this time it also user interface. You can see in this time in this legend there are the total. First of all I create the background, white color background, then I simply put here the title, then I also make the color this color column I created, then I simply put here this normal and polluted. So first of all you can see I simply set the position. This position in this time it's showing the left, bottom left. So if you want to need the position at the right, you can simply change here the bottom right, then it will be showing the bottom right. Okay, then padding in this time I want to add here the 8 pixel width and 15 pixel height. I want to use this padding. Then you can see the legend title, so I want to add the title water quality. So if you want you can use change the name, then also it will be changed in here. Then I also style this font, so bold, I use the font size, margin and padding. Okay, then I add this lesion with this. So then I also created the visualization. Okay, so I want to create the color band like this, color band I want to create it like this code from using this code. Okay, and then I simply use here the, you can see, create the, on the top I want to use the polluted, so I simply showing the polluted, you can see, as well as also use at the bottom I want to create it the normal. Okay, and add all of the, you can see, normal. Okay, so then all of the things will be same. Then I would map to add legend, so now this legend will be add with this map. Okay, so if you want to change, you can simply change the your according to your requirement, then you can easily get this, the same code you can easily use the for the any types of legend. Okay, so anyone, any question? Mm, okay, okay. Okay, so in this time I simply go to the next slide. So in this time I talk about this code. Okay, so in this code we try to discuss about this part, how you can easily calculate the all of the things, suppose NDTI, as well as it will be loaded just a minute. So NDTI, then how you can easily add with the total suspended solid. In this time you can see we can get the result only for the water body, you can see, only for the water body. But when I use this NDWI, it also get the some area where there is no water. Okay, it also get the some area. Okay, but in this time here you can see I can get only for the water body. Okay, only for the water body, you can see it not across the water body, but I use the same, I use the same boundary. Okay, I use the same area. Okay, same shape file. But in this time I use here the another technique. This technique is that AWEI, automated water extraction index. So that's why in this time it take only for the water, not go to the outside. Okay, but in this code you can see it also overlapping the some area where there is no water. Okay, there is no water, so it's showing the normal, you can see there is no water. Okay, this it's showing that as a normal place. Okay, normal. Okay, so in this time when you want to use this code, you can see this code it only showing this only for the water body, because it's we are also use here the another index, it's called the automated water extraction index. So that's why you can get the result in here. Then also you can see NDCI. And you can easily export all of the things from here. So water change area year to year. Okay, so then you can use at the, suppose you want to suppose you want to identify what is the water in the year of 2021 and what is the water change in year of 2015. Then we can easily do it using the we can easily do it the different way you can do. Suppose if you want, you can use here the classification. You can get the satellite image for year of 2021 and then you can make the classification for water body. Then you can also take the satellite image for year of 2015 and also classify it for the water class for year of 2015. Then you can simply calculate it the subtract with the area. Then you can easily get the area when, how much water area will be increasing or decreasing. Okay, so a lot of way for doing this type of change, calculating the change area. Okay, anyone, any question? Okay, and in this code we also added the all of the time series chart, you can see. So turbidity time series chart, so turbidity time series chart was also added in here. Then also we had the chlorophyll time series chart, as well as also add here the total suspended solid time series chart. Okay, milligram per liter unit. And if you can see this is a FN unit, so if you simply click to here, and then you can simply download all of the data as a Excel file, as well as also download the PNG file format images of all of the data set. Okay, so in this time I try to discuss about this code, and this is a very large code, so that's why I already write the code, all of the calibration equation, all of the equation I already write. So in this time I try to discuss about this code and then try to show you all of the things step by step. Okay, so let's go our slide. Okay, so in this code we are using the same satellite image, but we are also added here the some other index such as AWEI. So basically this is the index, automated water extraction index, and we can get the index from this source. Here you can see I also added this link, research paper link or journal link. You can get all of the information about this link, about the index from this link. Okay, I use the same equation or same all of the things for the extracting the water, automated water extraction index, and just I can put the equation and I can easily get the water. Okay, then I also add here the reference so that you can simply go to this reference and get all of the information about the automated water index, extraction index, how it will be work, what is the equation. You can get all of the things. Okay, so you can also see the some spectral water index, their formula. So here you can see in this time we are using here the, you can see the AWEI. So AWEI, automated water extraction index. So here I can get the two types of formula. You can see 4 into green band minus short wave infrared band, subtract with 0.25 near infrared band plus 2.75 into short wave infrared band. As well as also you can see the another band is that blue plus 2.5 multiply with the green minus 1.5 multiply with the green plus short wave infrared band, subtract with 0.25 multiply with the short wave infrared band. So in this time I use this equation and try to calculate it, the automated water extraction index. Okay, okay. Then we also try to discuss about that NDTI. So mainly NDTI is the normalized difference turbidity index. It is used to estimate the turbidity in water bodies. And you can see I already used here the NDTI calibration equation. I use the same equation, all of the same value. I can get this equation from the reference paper. I also send you all of the reference paper, how I can get the equation calibrated, all of the things you can get. So in this time I just implement this code. All of the things is already done for the different types of researcher or scientists. They're already created this type of calibration equation or other types of equation. They're already done. So in this time I try to show you that how I can implement all of the equation, all of the things in Google Earth Engine platform and try to calculate the NDTI, NDCI or total suspended solid. Okay, so let's go. Then also you can see total suspended solid, this equation, also you can see calibration equation. So all of the things in added in here, and I also send you all of the reference paper. You can also read this paper, then you can easily get why they are used this the value, why they are used this equation. Okay, so let's go our code. In this time I try to discuss about this code directly. So I simply open my code editor.